All right. Welcome, everybody, to the wonderful world of machine learning and data mining, the most fascinating subject you will ever study. My name is Pedro Domingos, and I will be your instructor. Please feel free to ask questions and share your thoughts at any time. One of the funnest things that happens in this class is when people share the experiences that they have with, doing data mining in their jobs and whatnot, and ask questions and so on. So I hope some of that happens here. Let's get some logistics out of the way first. So my email is pedrod@cs. Please feel free to email me at any point with any questions that you have. Also, I have office hours every week. I have set them from 5:30 to 6:20 right before class, since it's the most convenient for you. And my office is CSE 648, so please stop by anytime. If you happen to be on campus at some other time and you want to see me, we can do that by appointment as well, provided I'm in. Your TA is Rob Gens back there. He's in charge of making your life hell. So everything bad that happens in this class is his fault. Everything good is my merit. Okay. His email is RCG. Again, feel free to send him email. He has office hours again at the same time. Not ideal to have them at the same time, but it's again probably the most convenient for you. And the office hours are in 216. Okay. You don't have to write any of this information down because it's all on the class web at www.cs.washington.edu/p546. This is the short form URL. There's also a long form, and you can also just find it by following pointers from the department site and whatnot. There's also a mailing list that we highly encourage you to subscribe to. You can do this by following the link from the class webpage. It's CSEP546@CS. And we will be posting important information about the project, clarifications, and whatnot there. Okay. The decision whether to send email to the list or to us is one of whether you think the question is only of interest to you or of interest to everybody. If you think it's of interest to everybody, please send it to the list. We reserve the right to embarrass you by replying to a question that you sent us privately, publicly. Okay. So be aware of that. There's also a discussion forum that you can join to, again, discuss the class, and that can actually, with your colleagues and us, that can be a very, very productive thing to do. So we also highly recommend that. Okay, evaluation, our favorite subject. Right? How are we going to give you a lot of useless, long hours of work where you learn nothing? Is the problem we're trying to solve. And here's how we solved it this time. We don't have a midterm or a final. There's 4 assignments. Each one is worth 25% of the grade. We'll hand them out on weeks 2, 4, 6, and 8, and they're each due 2 weeks later. Okay? And they roughly cover the corresponding 2 weeks of the course, more or less, not exactly. Okay? The assignments are a mix of 3 things. One is implementing machine learning algorithms, right? That's one of the main things that you're going to do here is learn various machine learning algorithms, and there's no better way to learn them than to actually implement them and work with them yourself. The second part, of course, without which a course like this would not be complete, is applying those algorithms to real data sets and seeing what you find. Of course, you have limited time to do this, right? Some people do this, as a full-time job, and even then it's not enough. But nevertheless, we hope to give you a flavor of what it's like to really do data mining, machine learning in practice. Some of the data sets that we might be using, we haven't decided yet, are things like clickstream mining. Can you predict what people are going to do on your e-commerce website, for example? Recommender systems, right? You're going to build a system that recommends, for example, movies to you based on, how much you liked other movies that you've seen. Spam filtering, right? You can build a spam classifier that, tests whether something is spam or not. And then maybe you can use it as your own spam filter for your own email and do better than the generic spam filters from the search engines, and so on. Some of it will be exercises, math-style exercises, because for some things that's the best. Some of them will be questions, maybe related to the programming part, maybe not, that test your understanding and also help you to, dig deeper and whatnot. Some of the projects will have more open-ended questions that those of you with, a ton of free time on your hands, I know that's everybody, can use to go to town and go further. And, just as an example, in this class a few years ago, one of the data sets that we used was the famous Netflix collaborative filtering data set, right? The one with the $1 million prize. And, we had a great time implementing algorithms for it. One of the students who had never done machine learning before went on to be a member of one of the 2 top teams, right? And they only lost because they turned in their solution an hour later than the winning team. So the next one could be you, okay? And or if you end up making millions of dollars with one of your algorithms, like some of these people have, don't forget your old friends, please. Okay. So any questions on the assignments, evaluation, and so on? You have no questions now, but I guarantee that you'll have plenty of questions later. Source materials. So what are we going to be using in this class? Some of you probably already have this. If you don't, I encourage you to get these as soon as possible. If you're only going to have, there are many good textbooks in this area. Some of them more advanced, some of them more applied, etc., etc. The one that I would recommend as the first book to study is the book Machine Learning by Tom Mitchell. It's a fairly short book as they go. It's fairly simple and accessible. It's a very nice, efficient way to get the basics of machine learning. It's clear. It's not too math heavy. It has a broad view of machine learning. So in many ways, it's an ideal textbook. The only problem with it, and it's a big one, is that it's outdated, right? So it's about 10 years old or more. So there's many things that it doesn't cover. And also some of the things that it covers, it doesn't quite cover to the depth that we're going to need here. So to complement that, we have pattern classification, which is actually a new edition of the earliest classic text in this area. So I highly recommend that you get both of these books if you don't have them already. And then I highly recommend that you do the following. Skim the relevant chapters before you come to class. So on the website, we've actually posted a rough plan for the whole course. It may change, but roughly that's where it's going to be. And there's also draft slides up there and whatnot. Again, those may change, but you make the most of the class if you already have an idea coming in of what we're going to be talking about. And literally, you can do that by just skimming through the slides in the book in 15 minutes. If you don't do that, then you spend a lot of your cognitive power in class just getting your bearings. If you do that, you'll actually make much better use of your time here. And then after you've gone to class, then you can go back to the textbooks and study things more deeply and try to do the assignments and whatnot, and then ask us questions if you have them and so forth. Okay. We will also be complementing as needed the textbooks with various papers and whatnot. For example, there's a very good paper on one of the clickstream on the clickstream mining project that we're going to do and so forth. So we'll do this on a week by week basis. Questions about any of this?